The sum of first 6 terms of a GP is 9 times the sum of first 3 terms. Find the common ratio. So in this problem, we can use this formula. We know that sum of n terms of a GP is given by a, which is the first term, times 1 minus r to the power n divided by 1 minus r, where r is the common ratio. So let us say, what would be the sum of 6 terms? Let us call it S6. S6 is going to be a times 1 minus r to the power 6 divided by 1 minus r. Now what is going to be S3? That is the sum of 3 terms. Sum of 3 terms is going to be simply a 1 minus r to the power 3 divided by 1 minus r. Let us use this formula. Okay. Now it is given that S6 is 9 times S3. Okay. S6 is 9 times S3. So this implies that a 1 minus r to the power 6 divided by 1 minus r is equal to 9 times a 1 minus r cube divided by 1 minus r. Okay. Now we can cancel this a and this a, and similarly we can cancel this 1 minus r by this 1 minus r, but we have to remember that in that case r should not be equal to minus 1. Okay. R should not be equal to minus 1, because if r is equal to 1, then we will get 1 minus 1 is equal to 0, and we will be having a division by 0 problem. Okay. So we get 1 minus r to the power 6 is equal to 9 times 1 minus r cube. So we can write this as 9 minus 9 r cube. So bringing everything on the left hand side to the right hand side, we get r to the power 6 minus 9 r cube, and then this is 9 minus 1, which is plus 8 is equal to 0. Okay. Now this is a equation in r to the power 6, so the highest degree is 6. So this is a 6th degree equation, but what we see is that the second term over here is r cube. So we can actually reduce this equation into a quadratic equation. All we have to do is, let's say, let p is equal to r cube. So this equation changes to p square minus 9 p plus 8 is equal to 0, and then we can write this as p minus 8p minus p plus 8 is equal to 0. I am just factorizing this quadratic equation. So we get p minus 8 and p minus 1, right? Because this is, if you take p, sorry, this is p square, so this is p minus 8 minus p minus 8 is equal to 0, and from here we will get p minus 8 p minus 1 is equal to 0. So p is either equal to 8 or p is equal to 1, right? So this means that r cube, because p is r cube, is equal to 8, or r cube is equal to 1. From here we get r is equal to 2, which is cube root of 8, or r is equal to 1. But what did we say? From here we got that r cannot be equal to 1, so we have to reject this solution. So the correct solution is r is equal to 2. Okay, so this is our problem number 20. Let us solve problem number 21. The fifth term of a GP is 81 and the second term is 24. Find the series. Okay, so let us write the fifth term of the GP. Fifth term of the GP is given by a r to the power 4 is equal to 81, and second term would be a times r is equal to 24. Now we have two equations and two variables, we can easily solve for it. So if we divide these two expressions, we get a to the power 4 divided by a r is equal to 81 by 24, and this cancels. This is 3 times 8, so this is 3 times 27, and this r cancels, and you get r cube is equal to 27 by 8, and therefore r is equal to 3 by 2, right? So we know that r is equal to 3 by 2. We can find a from this equation. So we know that a times 3 by 2 is equal to 24. So a is going to be 24 times 2 by 3 is equal to 16. So what is our geometric progression? Our geometric progression is 16 times 3 by 2 is 24. 24 times 3 by 2 is 36. 36 times 3 by 2 is 54. 54 times 3 by 2 is 81, right? So this is our geometric progression, and it will go on. So this is problem number 21. Let us look at problem number 22. The sum of a GP whose common ratio is 3 is 728, and the last term is 486. Find the first term. Okay, so let us first write the formula for the sum of the GP. Sum of the GP is a times r to the power n minus 1 divided by r minus 1. Okay, we can also write this as a to the power r n minus 1 times r minus a divided by r minus 1. All I am doing is I am just expanding, I am distributing a on this expression. So this becomes a r to the power n minus a. Now I am again breaking this a r to the power n as a to the power a times r to the power n minus 1 times r. There is a reason I am doing this, because this expression I can write it as the last term. Okay, this is the last term of the GP. Okay, so this we can write as last term times r minus a divided by r minus 1. The whole reason that I did all this was because over here it is given that the last term is 486. So now we have sum is equal to 728. Now this we can write it as last term, which is 486 times common ratio is 3 minus a, which is the first term, which is what we have to find, okay, divided by r minus 1, which is 2. Okay, so this becomes 1456 is equal to 3 times 6 is 18, 3 times, so 5, let me check again. 3 times 6 is 18, so carry 1. 3 times 8 is 24, plus 1 is 25, carry 2. 3 times 4 is 12. And from here we get a is equal to 2. Okay, let me check if this is the correct answer. If our first term is 2, we know that our second term is going to be 6. 6 times 3 is 18, 18 times 3 is 54, and 54 times 3 is, it seems to be correct. Yeah, so let us do the next problem. In a GP, the first term is 7, the last term is 448, and the sum is 889. Find the common ratio. So this is again a similar problem like 22. So we will use this formula. S is equal to last term times R minus A divided by R minus 1. So we are given that the first term is 7, the last term is 448. So 448 times R minus 7 divided by R minus 1. This sum is equal to 889, right? So we have to solve for the common ratio. Now 448 R minus 7 is equal to 889 R minus 1, sorry, minus 889. Okay, so if I bring this, so this means that this is 9 minus 8 is 1, and 8 minus 4 is 4, 441, right? 9 minus 8, 8 minus 4, 8 minus 4. So 441 R is equal to 882, right? Because 889 minus 7 is 882, so R is going to be 2, right? Let us look at problem number 24. The sum of the three numbers in GP is 38 and their product is 1728. Find them. So let us say that our three numbers in GP is A by R, A and AR. Our common ratio is R. Okay, so I am taking the three geometric series is, that is three terms of the geometric series as A by R, A and A times R. Now it is given that if you add them, you get 38, and if you multiply them, you get 1728. So if you multiply them, you will get A cube, because R and R will cancel. So A cube is equal to 1728. From here we can find A. A is going to be the cube root of 1728. Let us find the cube root of 1728. Okay, this is an even number and a cube. So let us first try dividing it by 8. 8 times 2 is 16. So 1, 4, 216. Again an even number. Let us divide by 2 again. 8 times 2 is 16. 7. Yeah. So the cube root of A is going to be cube root of 8, which is 2, times again a cube root of 8, 2, and cube root of 27, 3. So A is equal to 12. Okay. Now let us put 12 in this equation. So you have 12 by R plus 12 plus 12R is equal to 38. If I divide the expression by 12, you get 1 by R plus 1 plus R is equal to 38 by 12. 38 by 12 can be written as 19 by 6. Okay. Now I multiplied the expression by R, so you get 1 plus R plus R square is equal to 19R by 6, and therefore 6R square plus 6R plus 6 is equal to 19R, and 6R square minus 19 minus 6 is minus 13. R plus 6 is equal to 0. So we have to find two terms so that the product is 36 and sum is equal to minus 13. So we can use minus 9 times minus 4. So 6R square minus 9R minus 4R plus 6 is equal to 0, and I can take 3R out. So this is 2R minus 3 minus 2R minus 3 is equal to 0, and from here we get 3R minus 2 times 2R minus 3 is equal to 0. So this means that R is equal to 2 by 3 or R is equal to 3 by 2. So you can take any of these values because each value is just a reciprocal of the other. So our geometric progression or the three numbers are going to be 12 if I take this value of R. So this becomes 12 times 3 by 2. The second term is going to be A, which is 12, and the third term is 12 times 2 by 3. So this is 6 times 3 is 18 12 and 8. Okay, so these are our three terms. If you had used this value, you would have just got these terms in reverse order. That is, you would have got 8, 12 and 18. Okay, so let us look at problem number 25. The continued product of three numbers in GP is 216 and the sum of the product of them in pairs is 156. Find the numbers. So let us again say that our numbers are A by R, A and A times R. Now we are given that the product of these numbers is 216. So we say that A cube is equal to 216, and therefore what is A going to be? We have already found the cube root of 216 is going to be 2 times 3. So A is equal to 6. Okay. Now we know that our numbers are going to be 6 by R, 6 and 6R. Now what is the other information given? The other information is the sum of the products of them in pairs is 156. So what it means is you multiply these two terms, so you get 36 by R. Then you multiply second and third term, you get plus 36R. And then you multiply these two terms, so you get 36. Okay, because this R and this R will cancel. This is equal to 156. So from here, if you divide the expression by 36, you get 1 by R plus 1, 156 by 36. So let us try to divide it by 3 first. So this becomes 3 times 12, and this is 3 times 5 and 3 times 2. So you can divide it by 4 maybe. 4 times 3 is 12 and 4 times 13 is 52. Okay, yeah. So we have 1 by R plus 1 is equal to 13 by 3. Now if you multiply the entire expression by R, you get 1 plus R square plus R is equal to 13R by 3, and 3R square plus 3R plus 3 is equal to 13R, and this means that 3R square minus 10R plus 3 is equal to 0. Now we have to find two numbers so that the product is 3 times 3 is equal to 9, and sum should be equal to minus 10. So we can have numbers as minus 9 times minus 1. So 3R square minus 9R minus R plus 3 is equal to 0. So take 3R as common. Over here you get R minus 3 minus R minus 3 is equal to 0, and finally we have 3r minus 1 times r minus 3 is equal to 0. R is equal to 1 by 3 or R is equal to 3. Again we see that the common ratio that we get after solving this is just the reciprocal of the other number. So we can use any of these numbers. So our terms are going to be 6 by 3, 6 and 6 times 3. So finally our terms are 2, 6 and 18, and we are done.